question 215, kth largest element in an array from LeetCode. Let's jump to the question. Given an integer array nums and an integer k, return the kth largest element. So let's see what this question is asking us. So the question is saying an integer array is given and integer k is given, and we are supposed to return the kth largest element in the array. So as you see in the first example, this is the array is given to us and we are looking for the second largest element. The first largest element is 6 here and the second largest element is 5, so this is the number that we are going to return. And for the second example, we are looking for the fourth largest element. As you see here, this is the first one, this is the second one, still it's the same, so it's going to be the third one, and this is the fourth largest element in this array that we are going to return. The key point here is the array that are given to us, they are not sorted, so we cannot just say, okay, if we are looking for the first largest element, we're going to return the first one from the end. This is not the case. The arrays are not sorted. So let's jump to the solution and see how we can solve this problem. I have 3 different solutions here that I'm going to explain. This is the first one, this is the second one, and this is the third one. So let's go through the first one first. So for the first one, we are going to use heap, and we are going to use heap properties. The module that we are going to use here is heap queue, which is very easy to use. So what we are going to do, if this is the example of the array that we have and we are looking for the second largest element, we are going to iterate over every single item and we are going to add it to the heap. But what we are going to do, we are going to add the negative of that number to the heap. The reason is by default heap function is sorting the items ascendingly, and as we are looking for the largest element, it's going to be at the end of the heap. So if we do it descendingly by using negative, it's going to be kind of easier, and maybe it takes like less time for like special cases like long arrays, right? And what we are going to do after, we are going after the for loop that we have added all the values in this array to the heap. As you see, we first add -3, then 2, and then 1, and then 5 is added, and 6 and 4, right? So, and we are looking for the second largest element, right? So what is going to do is we are going to use a while loop, or it can be a for loop, until we get the kth element, and we are going to multiply that by a negative because we change the nature of the number at the for loop here. So we multiply by negative and we are going to return kth element, which is going to be, for this one, it's going to be 5, and it's going to be -5, it's going to be multiplied by minus, it's going to be 5, and this is the second largest element in this array. And another solution that we can use, it's a simple one that we can use sort. We sort the array first, and then we get the from the sorted array we get the -k index from this array. And the reason that we are using minus, because the array, when it's sorted, is going to be ascendingly, and we're going to get from the end of the array, right? And the time complexity for the first one is going to be n log n. For first one and second one, both is going to be n log n, and the space complexity for the first one is going to be on, because we are storing this array in the heap. And for the second one, because we are doing it in place, the space complexity is going to be constant. It's going to be constant. It's going to be O1. And another solution is we can use the heap module. It comes with a function that is called n largest, that it will return the n largest element of the array. And as you see, we put the n, the in this case it's going to be like, for example, 2, and we're going to put the array, in this case it's going to be num, we're going to put it in here, and it's going to return the largest one, which we can use that too. And the time complexity for this one is slightly better, it's n log k. And that's about it. Thank you so much.